All right, well, that's coming up because the timer's already started. I will give you guys a little bit of housekeeping first, and I appreciate you all being here. The advantage of this week is that we are all absolutely blessed with a massive amount of choice for breakout sessions. There's over 3,300 breakout sessions this week, so I appreciate you taking the time to come to this one. This is Analytics 335, somewhere in there. It is a -S, which means it's sponsored. Just to clarify something, this session does not contain any sponsored content. I'm not here to talk about Trend Micro products or platforms or our position on anything. If you want to talk about that stuff, we have a booth in the Expo Hall at the Venetian, 2115. It's a big spaceship. The team there willing to talk to you about everything and anything that Trend Micro does around EC2, ECS, and container security. What I want to talk to you guys about today is security data and how to learn from it, how to gain insights out of it. Now, the interesting thing is, obviously I'm a security guy, I work for a security company. I'm also one of the AWS heroes, which there's a group of us, we're about 55, 56 of us now. We teach the community, we try to make sure that you guys can get the most you can out of the tools that you have available in the AWS Cloud. And the reason why I put this particular talk in the analytics track is because I think it serves two purposes. So show of hands, how many folks are actually in a security role? Oh wow, okay, fair enough. Cool. How many folks in a, it's good, you guys are reading the session catalog. It's like a little Easter egg hunt here. How many folks are in big data analytics or like a machine learning role? Okay, good, so it's odd. I figured it was gonna be the other way, where the majority of the room, 80% were in analytics. No worries, this talk has been designed for both sides. From a security perspective, you're gonna understand how to tackle the problem that we've all been suffering through for years, which is how do we deal with all the data that our tools generate and all the infrastructure we're protecting generates. From an analytics perspective, and I say that over here because oddly they self-biased into a cluster, the analytics perspective, this is a really interesting case study because security data is constant. It's a continuous stream of data from a variety of sources that all have different parameters and different properties that makes it really hard to normalize and to apply tools like machine learning or even basic statistical analysis to. Just the scale of the problem is really interesting. So that's what we're going to walk through today. It's basically the use case of security data. Now, I might disappoint you a bit here, but it's better to kind of rip off the Band-Aid and get it out right after the fact. This is not a talk about machine learning. I would love to be able to come up here and give you guys a talk about machine learning and security. But what I'm going to talk about is all the work you have to do to get to the point where you can start to apply machine learning. Because the biggest challenge we have with security data is that everybody has a different scale for things. There are all different parameters coming out from the different tools. It's extremely hard to make any sort of logical model out of without doing work ahead of time. Right? It's not like you're taking the ImageNet data set where it's all pictures and the pictures are clearly labeled, this is a cat, this is a dog, and you can build models off of it. This is a highly complex, multivariate data set that's continuously changing and continuously adding to the volume that you have to deal with. So there's a ton of stuff we have to do before we get to the really fun, cool parts that like Dr. Matt Wood was talking about last night, right? Matt came out on Monday Night Live, was talking about all the great machine learning things, and you can absolutely take advantage of those in a security context if you put in the work first. So we're really emphasizing the how part here. So that's what we're going to walk through. So this is a great quote from Stephen Schmidt last year. He's the CISO of AWS, and he said this, and it really hit home for me. And it was essentially, if you have people sitting in a room looking at screens, trying to make your security data actionable, you're probably too late. I think that's a really polite thing to say. I think the reality is a lot harsher. I would say you are too late because you're probably hours behind any actual security incident, right? So for those of you that aren't in security, I'll paint you a little bit of a picture of a normal security operations center, a normal sort of security analyst flow. There are tools deployed throughout the infrastructure that are doing various security things in different areas, which is good. There's firewalls, intrusion prevention, anti-malware, all these kind of security controls you've probably heard of, and for those of you in security, you use all the time. They're all generating data points. In relatively mature security organizations, those data points are all going somewhere. Normally, that's a security operations center. If you're large enough, you have your own. If not, you probably use a managed security service, or you have somebody doing this for you, basically. the role of an analyst, despite what you see in Hollywood movies, is to sit at a screen and look at line after line after line after line of potential security issues. Right now, rough ballpark, sort of back of the napkin math, I would say the accuracy of finding something worth that human's time is probably, we're hitting around 10%. So 10% of what they look at is actually worth looking at. And that's probably being generous, but I thought it'd be nice to give you a double-digit number instead of a single-digit number and kind of make it sad. So this is what Stephen called out is absolutely accurate. If you're sitting there trolling through these things, you're probably too late, because by the time you find that one event that indicated a compromise or a security issue that you need to respond to, it's hours old. And in the world of cybersecurity, hours means you're way too late. Your data's exposed, the hackers have what they want, or you land on the front page of the New York Times. So at the end of the day, we have this absolute mountain of data. And if we are adhering to best practices and best principles within the AWS Cloud, so things like the Cloud Adoption Framework or the WellArchitected Framework, how many folks have read the WellArchitected Framework, are familiar with it? That is awesome. So about half the room. I ask that almost every year. This is the first time we've gotten to about half. So for those of you that haven't read it, after this talk, I suggest you read it. It started as a single PDF. Now it's a whole host of them. And within the well-architected framework, it's essentially what Werner always refers to every year about his 21st century architectures, about how to build well within the AWS cloud. There are 5 pillars. So operational excellence, cost optimization, reliability, performance efficiency, and security. And each of these pillars work together to build out a well-architected application. So you have to make trade-offs between these pillars, right? You can't have everything you want for absolutely zero cost. It'd be nice. We're getting there based on the announcements last night at Monday Night Live, how many price drops they announced. But you still have to make trade-offs. You're going to trade off operational burden for performance. You're going to trade cost for reliability. Hopefully you make as few security trade-offs as possible. But if you adhere to the framework, you actually end up generating more data that you have to handle. It makes the problem worse, which is not bad, but initially it's kind of intimidating, because you've taken this mountain of security data that you already can't handle and added to it. And the reason you're adding to it is because under the security pillar in the well-architected framework, there is a core concept called enabling traceability. So essentially being able to find something bad and walk back through the sequence of events that raised that eventual alarm or alert. Right? So if somebody is attacking your web application, being able to start at that transaction at CloudFront, trace it through the load balancer, to your instances or containers, to the application code, all that entire chain needs to be recorded. That's enabling traceability. And you can think of every single point within that chain is going to generate new data. So if we look at it in a different way, we've got security tools throughout the infrastructure. We've got things like our security groups, our services like AWS WAF. We've got APN partner tools. We've got all this stuff, and it's generating a mountain of data. And right now, we are spitting out alerts. A lot of security alerting right now is extremely naive, right? It's very basic. If this, then that, wake someone up, right? Someone's been on call before. You sit there and go, if I see 100 alerts from the AWS WAF within 2 minutes, wake Mark up because it's important enough to get somebody to respond. Is it though? It's a really naive trigger. You're just looking for a simple volume, right? Or if we have a malware alert that happens extended for more than 10 minutes, wake somebody up, raise an alert. So it's a very naive and simple system. And if you haven't figured out yet, I tend to speak very frankly, so I will give that as a warning ahead of time. Basically, we have a mountain of trash. We have all this data that is very little value to us right now because we just keep collecting it. And we have extremely naive alerts. We have people who maybe are performing at 10% efficiency in our security operations center, and yet we have a massive cybersecurity skills gap. The latest reports are saying by 2020 we'll have about 3 million open jobs globally. Wonderful time to be a cybersecurity professional when you have negative unemployment. But the problem we're facing and the organizations we're trying to defend, we need to deal with this. So the idea that we're going to walk through today is that we've got all this trash. We're going to try to extract value out of it. We're going to figure out a process for extraction. And ideally, we're going to automate that process. And what we're going to do is we're going to use AWS features and functionality to do that. So we all have access to this tool set. There's no magic secret thing here. I'm not going to say, hey, if you sign up and you buy this, you're going to be able to do all this. This is leveraging core AWS functionality that's globally available today. Here's how we're going to do that. First, we need to define our problem a little more clearly, right? We know we have this mountain of data, and we need to figure something out. We need to get something out of it. Simply put, what we need to do is how do we automatically surface actionable data out of this mountain? And that keyword is actionable, because right now, all of our systems in security are set up just to spit out those naive alerts. What I want to see is something that's deserving of a human's time. Right? We have all these wonderful systems at scale. We want to make sure that we're spitting out 95+% confidence on alerts that people can actually action. Right? So that if they're staring at a screen, that's a very bad thing if it's full of alerts, because all those alerts require a response. Ideally, we get them to the point of just do this one thing or do this two things. So that's our goal here. We do that with traceability. Now, traceability technically is the verifying the history, the location, the application of a specific data point or an action. I don't like formal definitions. You've probably figured that out by now. What this really means is, where did this come from? Who can access it? And when can they do any of that? Right? Really simple questions. Easy things to ask. So if you have a container that's running in Fargate, well, who spun it up? Right? We want to know who spun it up or what system spun it up. Who can access it? Can anyone access it? Pro tip, nobody should be able to access it. Only a system should be able to access it. You should not be logging into anything in production, ever. When? Under what circumstances can things access it? So if your CI/CD pipeline can tear it down, when can they tear it down, what conditions? This is traceability. Having the data to answer all these questions is traceability. Does that make sense to everybody? Right? So those are some of the data points that we want. We also have another concept of observability. So observability is the ability to infer internal states from external outputs. We deal with this all the time in security, especially given how security organizations work. But an easy example is looking at encrypted network traffic. We can't look inside the packets, but we can see where they came from, where they're going to, and we can help infer some of the state based on the volume or what happens outside of that. So if we see encrypted traffic coming into a web server and that web server starts to behave abnormally or erratically, there is an inference to be made there about that traffic communications coming in. Essentially, it's black box, right? Can you infer from what's going in and out? Can you figure out what's going on in the box? So that's really it. I define that simply as observability is what's going on. Fancy, down to simple. Simple's easier. Always go with simple. We have enough complicated things. Simple would be far simpler. That's why we call it simple. So we have data sources. And this is where, from an analytics perspective, things get really interesting. The security folks are just going to go, oh, God, not again. From an analytics perspective, this is what makes it a fascinating case study, the set of problems and the breadth of the inputs that we have. And I'm just going to go through a few of the core AWS ones. This is not the entire exhaustive list. So we start with a service like Amazon CloudWatch. So Amazon CloudWatch, we all know, right? Everybody knows CloudWatch in all its various forms? Right on. I saw nods. I'll take nods for now, but then I will come back for hands up because I need to make sure you guys are staying awake for this. So basically everything in the AWS Cloud interacts with CloudWatch some way, right? So something in the AWS Cloud is sending information to CloudWatch on a continuous basis. They are always sending information in, and that is either going to be some sort of alarm, so based on the metrics, that's going to be a log if you're using CloudWatch logs, or it's an event if you're using CloudWatch events. And out of these, then we get additional information. So these are our types of findings, essentially, and then we get different data out of that. We get a timestamp. A lot of the time, we get an Amazon resource name. So that's our who or our what. We also get a severity, and I put an asterisk next to severity because severity is a very relative concept. Severity compared to what? Compared to what you, the user, have set, compared to what AWS has said. It's an interesting metric, and it's going to pop up again and again throughout the data sources we look at. And then depending on what sent the information to CloudWatch, you could get anything or nothing else, which as a data problem is really interesting. I have either zero additional information, or I can have another 300 data points hidden within this aspect. Right? So if it's an API call that's triggering a CloudWatch event, you're going to get all the details of that API call. So if somebody's spinning up an EC2 instance, you'll get the identity of who spun it up, but you'll get the parameters. If it's using parameter store, you'll get that. You'll get the user details, the security group, you'll get the instance size, you'll get the AMI, you'll get all this information, everything that was in the API call, right? And that's great, but that's, again, another set of data, and that's a dynamic set of data because it's different for every single AWS API call that's out there. So this alone, just trying to consume and understand information coming out of CloudWatch, is a massive problem in and of itself. But that's not the only data source. I'll bring a lot for you instead of just one. Why tackle one hard problem when we can tackle all of them, right? So most commonly, we get AWS or Amazon VPCs. As of last night, I don't know if you guys saw Monday Night Live. How many folks watched Monday Night Live with Peter? A couple? Everyone was too busy at venues having beverages. So one of the things they announced about 4 or 5 services. Monday Night Live always focuses on hardware and sort of core infrastructure innovations. One of the major things they announced around VPC is the concept of a transit gateway. So previously, VPCs could be peered subnet to subnet, but you couldn't hop from one subnet in a VPC to another VPC subnet to another one. Now they've got the concept of a transit gateway that can be deployed globally, connect hundreds of AWS accounts and hundreds or thousands of VPCs to enable routing among them all, right? So it gets us far closer to traditional data center networking structures, which means the volume of VPC flow logs that we're going to deal with is going through the roof because now your accounts can be all centralized, which is a great win. Don't get me wrong, the transit gateway is going to simplify a lot of your network architectures, but again, it's adding to this mountain of data. So when we have VPCs, there's network activity. The VPC is continuously monitoring the network activity and generating flow logs depending on the volume at different paces. In the flow logs, you get information like a timestamp, so it's not a full network flow log. It's a simplified one. You get your timestamp, your source, destination, the port, and the volume of data, so the data size of the transaction, right? Who spoke to whom, for how long, at what time. It's a great source of data. Next up, we've got Amazon Inspector, which is actually a security service from AWS. It has an agent that sits on your EC2 instance or your ECS host. You ask it on demand to run what's called an assessment, and it's going to then inquire and search the instance it's running on to find software versionings versus vulnerabilities. It's going to look for configuration issues. It's going to look for a whole host of issues. And these assessments can run for either 15 minutes up to 24 hours. And the longer it runs, the more behavioral analytics it will generate and spit back. It does that in the form of a finding. A finding will tell you details like the name of the finding, the rules package it was from. So the rules packages are normally bundled up for things like PCI compliance, CIS compliance, things like that to give you some context about what it found. Again, severity on a completely different scale than CloudWatch. Not normalized, it has a completely different scale. Timestamp description, CVE is a security nomenclature. It's the common vulnerabilities and exposures. It's an international semi-standard for us to refer to issues, so at least there's commonality there. But if you then look at the CVE, you'll get even more data. And then here's the first time Amazon does this, which is great. There's provided recommendations. So this is the first time we have directly actionable data from any one of these sources. It's also the only data source that provides directly actionable data. It tells you what to do, which is great. Most of the time, those recommendations are pretty straightforward. I found version 1234, version 1235 is out. You should install it because it fixed this vulnerability and this vulnerability. So that's Inspector. Next up, we've got GuardDuty. GuardDuty is looking at your AWS account. So Inspector looks at your EC2 or ECS instances. GuardDuty is looking for issues in your account. It does that by checking out your CloudTrail logs, your VPC flow logs, and custom IP lists that you give it. GuardDuty runs continuously, which is nice. Once you turn it on, it's always looking at that account, its information. And when it finds an issue, it's going to raise a finding. I love when engineers name things. It makes it perfect sense. It found something, so here's a finding. That doesn't always hold true with AWS services. And in these findings, you'll get the title, the description, a list of affected resources. IOC details is an indicator of compromise details. So in this case, you're going to get information about the threat it found. So if it found problem with an EC2 instance, if it was trying to make odd DNS calls, it's going to give you the details of the DNS call. It's going to give you the details of the EC2 instance. Depending on what it finds, that IOC detail set is completely different. And the timestamp again, right? So another set of data that we have to deal with here, but important information. Now, I apologize, this should be labeled Amazon MaySee, but Amazon MaySee is targeted at AWS S3, at Amazon S3, which we all know has been a challenge, let's say, for a lot of folks from a security perspective, to the point where AWS has launched no less than 4 features in the last year so that people stop making buckets public. Yeah, I'll take 30 seconds for a side rant here. Buckets are private. They start private. You have to explicitly make them public. We all know that in this room. For those on YouTube, they're private. You make them public. Many people make a mistake and make them public. MaySee helps find that. So does the new account level lockdown. So does the 4 warnings or 3 warnings you get in the UI with the little bubbles that say this is public, this is public, this is public, this is public. There's a ton of tools that will help you figure out your public buckets. Don't make your buckets public, unless they're hosting a website or need to be public. So there's a lot of tools there. MaySee is one of them. Rant over, back to MaySee. MaySee is in limited distribution. Right now it's only US West, US East. It's the one tool that I mentioned that is in limited distribution. Everything else is widely distributed. But MaySee scans your S3 buckets and the objects in the buckets that you tell it to continuously. And it's actually reading the data that's in those buckets, looking for risks. So it's scanning documents in a bucket looking for credit card information, looking for health information, looking for anything that it has deemed risky. And you can add custom things that you have, so IP for your company, or various things that you want to look for specifically. But out of the box, MaySee's got about 780 different things that it looks for. Pretty much everything most people will want to make sure they're keeping track of. So if you have a document full of social security numbers, MaySee will flag that for you and say, hey, you probably don't want that sitting there in a bucket if that bucket's public or if it doesn't have the required restrictions on it. If MaySee finds something, it's going to raise an alert. Those alerts include the title, it's a description, the Amazon resource name. The interesting thing about MaySee is it also tells you the number of occurrences, because some of the MaySee alerts are aggregate alerts. They're not individual alerts. So now we've got a data source that is doing some aggregation for us, some of the time, under some circumstances. Yeah, it's hard to deal with. This is the scale of the problem, right? This is a really big challenge. And then MaySee again throws its own severity listing in here, which doesn't line up with GuardDuty's severity, nor does it line up with CloudWatch's severity. AWS is working on that normalization of severity within their own products, but now we have to deal with it. Another service, AWS WAF. This is the Web Application Firewall. It works on the AWS Edge. The AWS Edge is 150 points of presence around the world. This is where CloudFront's deployed from, where Route 53 is deployed from. It's essentially closer physically to your end users. WAF works there, applying rules. Think of it as stopping web application layer attacks. Things like the OWASP top 10 can be blocked by WAF. You add filtering rules. You add my all-time favorite acronym, the WACL. It's a web access control list, so you can set a set of IPs, say don't let these IPs in. And then your traffic forwards from WAF either to CloudFront or to other backend sources. It's doing this continuously. Interestingly enough, this is the first preventative control that we've talked about. Everything else detects a problem. It essentially raises its hand and says, I think I found something. WAF actually stops things. You can ask it only to detect, but by default, WAF will prevent. It will drop traffic it deems malicious. So now we have a data source, and this is generating alerts. The alerts are telling us exactly what we think. It's the rule group, the name, the access control list. It's under the region, and again, volume, because it will do aggregate. But the interesting thing from a data perspective is now we have an after-the-fact action report. So action's already been taken on these alerts, but they can still tell us stuff about the rest of our deployment. So we've had tools that are generating volume detections. We've had tools that have an extremely broad set of properties like CloudWatch because they've got a breadth of services they're supporting. We have things like MaySee alerts where they're aggregating some but not aggregating others. We have WAF that is giving us preventative. It's already taken action. Inspector gives us alerts that we can take immediate action on. We have everything you don't want in a data set present, because we have to account for absolutely every one of these variables to make sense of this. Otherwise, we fall into the standard security trap which is analyzing the output from each of these tools in silos. Most security teams do that today. They will look at the output from WAF and they will treat that as its own thing. And they will not add the additional context of the rest of the tools because the problem is just too difficult to tackle. That's what we're trying to solve. So we get a generic formula here. You can apply this to any AWS service or APN tool or open source solution. Essentially, you've got a source of data going into a service with a data rate, and we've got an output, and then you've got data points in that output. You want to create a map like this internally to keep track of where your data is coming, where it's coming from, right? This is part of traceability in a solution we're building. You want to make sure that you know where your data is coming from so you can assign quality values to it, or you can assign confidence factors to it. If you don't do that up front, you're going to end up later on in the workflow going, where did this come from? Do I trust it? Do I, how do I treat it? Where do I go? Keep track of your data. This is the default formula. You should be able to, in your own practice, pull up a document that tells you, this is what WAF does, here's the output it spits out, here's how we treat it, this is where it fits into our overall thing, to our overall pipeline, which brings us to the actual pipeline. So we're going to create a process here that's pretty straightforward. We're going to initially manually review data as it's coming in. Okay, we need to normalize it, we need to enrich it, we need to standardize it, we need to score it, we need to get it set up so that we can actually start to implement an automated learning process behind, right? Like we said in the intro, it's not like ImageNet where we have a nice set of data, it's already classified. We have this diverse, rich data set with all these different data sources. We need to make sense of that. So we're going to set up an automated flow that's going to let us start to process through this. So instead of just sitting there staring at a list of alerts, we are actually going to be able to start to add value to that data while we're doing our current process to set ourselves up for a tool like machine learning. So I'll give you the architecture overview here. We have a bunch of our AWS services. They are spitting out data through other AWS services or directly. We are going to capture that data in a Lambda function. Okay? So either the tool is pushing out to CloudWatch events, or it's pushing into an S3 bucket, or it's, if you get to a certain volume, you can start to leverage Kinesis. But the concept is we're pushing data into a place where we can attach a Lambda function. The good news is, basically everywhere in the AWS Cloud, you can attach a Lambda function now, right? Anything that's event-driven, you can push a Lambda to, or push it to a Lambda. And the first thing we're going to start to do is normalization in there. That's where we're going to apply our normalization step. We're going to take an immediate detour and just point out the fact that if you set this up, you also are setting yourselves up to automate your security. So you can have another Lambda that will react to various events, because there are sometimes a slam dunk of a data event. You don't need to do further analysis, right? If you see an unauthorized login, you can take immediate action. You can either kill that instance, you can lock down the security group. There are things you can do there to automate your security practice. This is how you hook it in, right? We're going to centralize all of our data flow through, we can push it through to a Lambda. We're going to have that Lambda branch off to take action if we need to. But we're going to ignore that for the purposes of this talk. I do have a previous talk from last reInvent that covers that kind of thing, and you can hit me up online and I'll pass that over to you. But for this, we're going to look at the data analytics, which means we're going to take all that data of Lambda and we're going to be pushing it in an S3 bucket. As a pro tip, and I'm pretty sure this does not violate the AWS exam principles there, if you're doing the big data exam or the machine learning exam, anytime they ask you where you start your data analytics flow, it's S3. It's always S3. S3 scales bigger, is cheaper, is easier to work with, and every other service in the AWS pipeline will pull data out of S3. And now with the intelligent tiering that they announced on Sunday night, you don't even have to figure out what tier of storage you want in S3, whether you go to lower tier or push it to Glacier. Amazon or AWS will do that for you. They have a machine learning model they apply that will automatically tier your data for you. So we're going to throw everything into S3. And from S3, ideally, we're going to push it to SageMaker. That's our goal. That's where we want to go. But we're not there yet, because we know we need to do a lot more to this data to make sure that it's effective, that we can actually build effective models. We need to get a handle on all these variety of data sources. And more importantly, we need to figure out what's important and what's not important. You can't build a model if you don't know what you're looking for, right? What defines a security event that merits somebody's attention? That seems like a really simple question, isn't it? Like, what should you be looking for in all this event data? The answer is really, I don't know, honestly, it's a ridiculous thing to be able to say on stage. By nature, I'm a forensic scientist. I've done this at scale for my home country in Canada, for large organizations. I've been doing it 25 years. I still can't tell you what you need to look for. I can give you broad strokes. But to tell you exactly what you need to be looking for or give you a definitive list, if you see this, you need to run and freak out, that's just not possible because of what we're defending is always different, the tools we're deploying is always different. And so we need to figure out a way to build a process that lets us evaluate that for our own organization and for our own applications, which is exactly what we're doing here. So ideally, we'd push all this to SageMaker. We'd be doing these genius machine learning models, and that would do all the work for us. Not the reality. So what we're going to actually do is pull out from the S3 buckets. We are going to be pushing or leveraging Amazon Athena. How many people have used Athena? Good, that's awesome. Athena is like the quietest ever service. They never really talk about it too much. Essentially, for those of you that aren't familiar with Athena, it's essentially a way, it slaps an SQL layer on top of S3. Right? There's some stuff you have to do to make sure your buckets are queryable and things like that. But essentially, you can start throwing SQL queries at data that sits and stays in your S3 buckets. That's absolutely critical. It stays in the bucket. You don't have to take it out and put it somewhere else to do the analytics on it. You can do the analytics within the bucket. And we're going to also use the number 2 quietest service, Amazon QuickSight. How many folks have leveraged QuickSight? Good, that's not bad. So QuickSight was oddly enough the first service for AWS that used AWS's own top-level domain, .aws. And again, they never said boo about it. It was very quietly launched. It's been alive for, I think, 2 or 3 years now. What it allows you to do is visualize data in your S3 buckets, among other data sources, but we're going to leverage it in the context of S3. You can visualize the data within S3 without ever moving the data out of S3. So now we've got 2 tools, one that lets us query the data and another that lets us visualize it. That's the fundamental tool set that we need for our analysts to see what the data is doing, to explore the data, to run experiments on the data. This is the flow that makes sense for us, right? We get from our services into a Lambda. We have the ability to do things in the Lambda like normalize. Then we can sort and score. We can enrich that data, and we dump it in an S3 bucket. Once it's in the bucket, our analysts can then leverage Athena, they can leverage QuickSight, they can leverage a whole bunch of other tools if they need to, but to analyze that data, to draw out those insights, to answer that question of what should we be looking for. Okay? That's the flow we're looking for. That's what we're going to do. On top of that, we're going to layer on a loop, okay? Because this is not a one-time activity. This is a constant activity because you're going to continually see different aspects and different data end up in that bucket. We're going to need to be able to make sense of that on a regular basis. Our analysts are already analyzing this data on a continuous basis. They are looking at low fidelity events. We're going to leverage that process. We're going to overlay on the architecture we just saw here to make sure that they're adding value as they're going through their daily work. The first loop is essentially this one, right? We have our Lambda function. It goes to the bucket. We do some sort of analysis on it, and then we add to the Lambda function. So we add additional scoring, we add additional cases. So if you sit there and say, okay, when you see a log that does A, take action B, or score it thusly, you keep this flow going. So the easiest first one out of the gate is figuring out how to normalize severity, right? Some services are using a scale of 0 to 1. Some are 0 to 100. That's an easy one. Some are using 1 to 5. Some are using 1 to 10. And all of them have different meanings for what those numbers mean. Even if you normalize the numbers, sometimes they mean entirely different things, which is amazing. That's the only polite way to say it. It's amazing when you sit there and go, okay, an 8 on this scale, even if I normalize it to an 80, means something completely different because on the 1 to 10 scale, an 8 means you should really freak out, and if you don't fix something soon, just close the door and leave. Versus on the 80 scale, they're like, yeah, it's important, but if you have to leave it till tomorrow, that's fine. That makes no sense. You can adjust for it in this loop as you start to see the severity. We're also going to create a second loop at some point where we get to that goal where we've got the Athena manual review to start tuning the SageMaker models. right? That's the target, the end. If you apply everything we're going to be talking about today and you start to leverage SageMaker, you've got this secondary loop here where you're visually analyzing the data and the outputs from the model to retune the models, right? Because again, even if you set up a model, we saw that from Matt last night, you set up a model initially, there's the process of going through that tuning to make sure that you're getting high confidence values out of that model. It's never just this one set process. It would be wonderful. We could set that up one time and we're good. But these are the loops that we want. So we've got one big feedback loop, and then eventually we'll have a second loop where we're improving our models continuously. So our challenges here is that we want to make sure that we're only going to surface actionable data, right? We want to get rid of that crap. We want to make sure we have high confidence actionable data, and we want to automate this as much as possible. So the good news is Lambda is really easy to leverage. How many people have written a Lambda function? That is awesome. I know I keep saying that's awesome, but normally, like this is a huge leap over last year, especially for the security folks in the room. I'm very glad that you were all responding to that. I assumed all the data folks have written Lambda stuff before, but it's great that security are saying, yes, now we're writing code because that's huge. That is the way forward for success in the AWS Cloud, is being able to automate some of this stuff. So this is what we want to do, is we want to automate this loop. First, we need to go and answer that core question, though. What's the value of all this data? Can I safely ignore it? Do I need to action it? Does it inform other areas? And this is sort of the challenge we have with security, is a lot of the time in security, what we're actually looking for is the lack of any data. We're looking for the blank spots if we visualized it, right? We've got a big cluster and then there's a big hole in the middle. That hole is far more interesting because the vast majority of the time our security controls are going to catch known attacks, right? That's why we're leveraging security tools, is because vendors and the industry out there are checking every attack and they're building those attacks and protections from those attacks into the tools, and that's what we've deployed them for. So what we're trying to do from an analysis perspective is find those gaps, find those outliers, find those holes, because that's normally indicative of abnormal behavior. So the critical question here is going to be, what data is actually valuable to our security posture? I can't give you an answer to this because it depends on every application you're building. So if we use an example from last night from Monday Night Live, they had one of the director of platform for the video game Fortnite. Everyone's heard of Fortnite, right? If you haven't, ask any 12-year-old and you'll get more than enough information about Fortnite. Fortnite runs in the AWS Cloud, and it runs 8.3 million concurrent players at any given time. If you're defending an application like Fortnite, besides denial of service, one of the biggest things is fraud. They're looking for fraud because they have an internal economy, right? Somehow a free-to-play game is making several hundred million a month by selling items that have no impact on gameplay whatsoever. It's brilliant. It's genius. It is actually a free-to-play game, which I love personally, because it's actually a free. It's not a pay to move forward, but they do sell in-game items, and it's social pressure around them. There's social standing from having certain skins and look to your character. So there is an incentive there for people to level up their character, to access the funds if they can, and there's a huge amount of, they call the internal game currency V-Bucks. There's a huge amount of V-Bucks scams out there. So if you're defending Fortnite, what data is valuable to your security posture? Anything related to the in-game economy is going to be very valuable. You're looking for odd economic patterns. You're looking for accounts that suddenly went from 1,000 V-Bucks to 10,000 V-Bucks with no associated back-end transaction, that kind of thing, because that's what's valuable. If you're a pharmaceutical company or a medical device manufacturer, so another example from last night, GE was on stage talking about leveraging SageMaker. They have a huge amount of health information data. They also have a huge amount of proprietary data around the devices that they create. That's what's important. So any data that relates to those aspects of their infrastructure is absolutely critical. Now that doesn't mean that the other data isn't important, and this is the fundamental challenge in security, is that you have core pieces that are important, but we know from time and time again is that attackers gain a foothold on the network somewhere, and then they start to attack from the inside. They move laterally. So even though a data point might not be important to your critical assets, it could be important to the attacker to leverage to get after those critical assets. So you have to start with the critical ones and move forward. So yes, we need to answer the question of what data is giving us severity, high severity or critical severity information points. And then another key thing within security ends up being rapid repetition of any event. Unfortunately, we've been defending for a very long time manually, but attackers attack in an automated fashion. So a lot of the time, the trail we'll see through all of these security tools is repetition of events. So trying to log in, it's normal on Monday. It's also normal in the mornings this week, given what we all get up to at night, to try to log in multiple times because you forget your password, right? You fat finger your password, you don't get in, you fail 2 or 3 times. But if you see it burst and there's 50 attempts within a minute or 2, that's an indicator that something else is going on. Someone's trying to attack, right? Someone's trying to get through. Same where we see with database queries in the back end, if the volume spikes, that's normally an indicator that something else is going on. It could be malicious, it might not be. So these are easy start criteria to look at the value of the data. Is can we get severity indicator out of it? Is there a repetition there? And then there's a whole bunch of outliers that we need to track for. I'm gonna make this talk a lot simpler and we're gonna ignore outliers, just because there's enough out of the first 2 to get you going along this path. And by the time you're going to be examining outliers, you will have matured to the point where you can figure it out on your own. Also, a lot of the security tools you're going to deploy are specialized in finding outliers, right? So you don't have to build custom analytics to do that. Here's an example of an Amazon GuardDuty finding. Now, this is only 33, 34 lines of it. It goes on to about 200. Okay, it's a massive JSON document. And anytime GuardDuty, so GuardDuty is the AWS service that looks at issues within our AWS account. Anytime it finds an issue, it raises one of these findings. Now, some of the information is pretty straightforward. It's giving us the type of information. You can see on line 9, it's found a Trojan on one of the EC2 instances. It found that not by looking at the instance, but by looking at what the instance was doing. So it inferred it from an I'm not even going to go there. Yeah, it's early for me too. So it did that by observing the black box. The EC2 instance from GuardDuty is essentially a black box, and it saw the inputs and the outputs, and it is found and said, hey, there's a Trojan sitting here, and then it gives us all the details of the EC2 instance. And also, if we go down to line 116, it gives us a severity of 8. Important or not important? I don't know. Nobody knows. It's 8. There is an actual specification for this for GuardDuty, but this is fundamentally, this sums up the problem we're dealing with security data is 8. Okay, do I care? Do I not care? Right? You need to figure this out within the context. For the record, it's 8 out of 10, but if this was MaySee, that could have been 8 out of 100, because there's no upper bound on that. You need to understand the spec, right? And you can see the additional information it gives you here. It's giving you, in service. So if we look at line 99, it's telling us where it found, why it's making this inference, is it saw a DNS request from the EC2 instance. So that instance called out to somewhere that was known bad. Did it actually conduct a transaction? We don't know. There's not enough information in this finding. So we need to account for this in our analytics pipeline. So when you're breaking down this type of finding, you've got an inference. They've observed this action from the outside. They haven't confirmed anything on the source instance itself. They've just seen a malicious, what they consider a malicious DNS request outbound. And they've rated that an 8 out of 10 severity. And they're calling it a Trojan. So we need to figure out for ourselves what a unified risk or severity rating is. So is this a thing that we care about? Do we care about people sitting on our EC2 instances? Maybe if you cycle them every 2 or 3 minutes, you really don't. And that's totally valid. Depends on how you've built up your application. If your EC2 instance has an IAM role that gives us access to critical information, then you probably very much care about that finding. But there's no easy rule here. I can't hand you a set of JSON documents that define severity for your application. So we also want to add identity data into this as much as we can. So now we're at the stage where we're enriching our data as part of the normalization here. And right off the bat, the application identity is critical because we need to figure out what this relates back to. So in this case, the finding is found in EC2 instance. We, in the security team or the analytics team, should know what that instance is supposed to be doing, right? And that's really a core aspect of all this stuff from cybersecurity. For the analytics folks in the room, cybersecurity has a lot of complicated definitions. I think the easiest one is this, and it's simply to make sure that whatever you've built does what you want it to, and only that. That's all the wizardry of cybersecurity in a nutshell, is make sure that whatever the team has built does what it's supposed to, and only that. So here, we need to know what part of our build this EC2 instance, where does it come from? Right? Is it part of our front end? Is it part of our back end? Is it a batch job that runs at night? So this is a good opportunity for us on ingest, not only to unify that risk rating, but also to identify the application where it's coming from. And then ideally, we want to be able at some point to give a score to this data. That's where our machine learning model is going to come in on the back end. We need to give some sort of importance rating, and that comes in the form of a score, somewhere 0 to 1. For scoring, we're going to look at aspects like, does it touch critical data? Right? Is this the cafeteria menu? Don't care about it. Is this what our business is built on? I absolutely care about it, right? And that, again, is a challenge within cybersecurity. A lot of the time we go full nuclear blast bunker on everything. A lot of the time it's not merited. We need to make more discerning decisions about where we apply our efforts to. Another critical aspect for scoring. So in this case, we had a GuardDuty finding that looked on a malicious request. If we had something from Amazon Inspector that was looking on the instance or the container host, do we know it's exploiting a known vulnerability? Do we know that this is the initial attempt to unlock something that is vulnerable? Right? So you see that with, over the headlines over the last couple of years with Apache Struts 2. It's an application framework. Very simple to exploit the vulnerabilities that came out over the last 2 years. There's 3 major ones. If you wanted to exploit all 3, it took you about 15 lines of code. Very simple to do. If you saw that coming on AWS WAF, so people are sending those types of requests, the logical question is on the back end, is there a vulnerability to exploit? Right? Or I'm not running Struts 2. I don't really care if you're trying a Struts 2 attack. Right? So just because you see an attack doesn't mean it's actually important. It sounds really weird to say that as a security person, but I think that's fundamentally true. Just because somebody's trying to attack you doesn't mean it's actually important because maybe you don't have that asset to attack. And then the critical question in security is, have we mitigated it somewhere else? So yes, that's a vulnerability coming in. Somebody's trying to knock on the door on WAF, and we're seeing that there, but we're running an intrusion prevention system on the host, and we know that's going to drop that attack. So it's really not an issue. So you can start to see the complexity of analyzing this data set, right? We not only have the actual data with its multivariate properties, but we also have all these different concerns around scoring it. How do we figure out whether it's important or not? Because at the end of the day, what we're actually trying to do is boil things down to something as simple as this. We want to ideally, when we get to the machine learning phase, be able to cluster events as they come in as high risk or as low risk, right? High risk goes to humans, and they get to tackle it and deal with it. Low risk gets ignored or handled by an automated system. Right? Is it a dog? Is it a cat? Or is it a cat or a dog, depending on if you're a dog or a cat person. So, we've talked about the data values. We've talked about things going through. We've talked about scoring, the challenges around risk. How do we actually do this? Like, what's the process? We know this is the architecture. We've got services sending data. We're hooking into a Lambda. We're doing, normally that's 1 or 2 Lambdas, depending on how you want to manage your code. We're doing normalization. We're scoring. We're sorting. We're doing some enrichment, like adding application data, things like that. We're spitting into Athena and we're using QuickSight and Athena to analyze it when it's in the bucket. So here's a screenshot from Athena. This is the default one from Athena. You can see here they're walking you through building a query. It's straight SQL. It's ANSI SQL. You can use Hive if you want to, if that's what you're working on your workflow. But with SQL, you can build subsets of the data. So as an analyst, you can start to go through your data and say, I only want to look at WAF data for now, or I only want to look at data out of this service by using a simple SQL query, right? Because we put all our security data into one big bucket. Now we can use Athena to start to slice that bucket up, right? Reduce the problem set for us as humans to start to pull out critical things. Or because we've added application information, more importantly, we can write a query that will just pull out the data for that one application, regardless of the service that pushed it out. So now we can start to see where the events connect, right? So if we see this indicator on WAF and then this indicator from Inspector and this from CloudWatch, we know this is more of an issue. Excuse me. So with Athena, you can leverage any standard SQL tool. If you really want to, do yourself no favors, you could even plug it directly into Excel and then deal with that nightmare. But it works, right? You can just go to the tab and add a data source and point it to an Athena query, and you'll get the data you want. And if you're comfortable with Excel, it works. You're good. So the nice thing there is that you don't have to change your data set or your tool sets. But if you wanted to, here's an example of QuickSight. To generate this graph, it took all of 3 seconds. One of the inputs for QuickSight is S3 buckets. And then you simply select your parameters to start to visualize to figure out what's going on with your data set. Here's a time series going across different variables. And you can just mouse around and change the visualization to start to find those outliers for whatever makes sense for your data set. So using that 1-2 punch of Athena to write those queries, and you can feed those queries into QuickSight. So you don't have to look at the whole bucket. You can say, just based on the output of this Athena query, visualize it in a heat map. Or give me a time series, or give me a simple line, or give me, if you want to, a pie chart. Pro tip, it should never be a pie chart. It's an option, but just don't. So these are great tools. They're freely available and widely deployed right now. Now, for the Lambda code itself, this is the real basics. We start, because we're doing the cleanup, because we're trying to curate and normalize our data set before we get to machine learning, we really end up with a lot of if statements. Doesn't have to be any more complicated than that. So this is written in Python. So you can see here on line 21, we're looking at if it has a security event, if it has a severity property, and if it's got an Amazon resource name, then what we want to do is we're going to assign a custom risk rating. In this case, I just use the course code, a risk rating, and we're going to actually take that and divide it by 2, because the severity is 1 to 10, and we want, for some reason, we want to go 1 to 5. Right? Very simple. It's an if and. Everybody understands that. Even if you don't write code, I think that's pretty simple to understand, right? So it's a good way to start to ease in. And then you just keep adding up. So we're looking at if this app in line 27, so if there's a resource in the event, if it's the resource type, then we're going to pull out the instance details and get the tags from the instance. Right? And then we're going to add that into the event data. So very simple enrichment, very simple normalization. This is not rocket science, right? But it's going to set us up to do that human analysis. Better yet, it's going to create a curated data set that we can shove into SageMaker as we mature in this process. Does that make sense to everybody? Right? Does it seem complicated? Right? I think the key here is that the tooling is simple, the problem is complicated. And that's the ideal space if you're tackling a problem. You want to make sure that the problem stays where your efforts are going, as opposed to managing a complicated tool set. You don't need to spin up all the advanced analytics tools and machine learning models at this stage, but you're setting yourself up for success when you get to that stage. So our keys for this entire process. We want to identify the data sources, right? We walked through some of them. We looked at CloudWatch, we looked at Inspector, at MaySee, at GuardDuty, at WAF, all these things. There's going to be a whole host of your own applications as well. Right? And any other AWS services that you're leveraging, as well as things like CloudTrail. So all of these things are going to be creating data that have a security relevance. We create that feedback loop. So we have events going to a Lambda or a series of Lambdas, putting into a bucket. We have that manual feedback loop of Athena and QuickSight with the bucket to upgrade that Lambda to keep improving, eventually getting to SageMaker for that other feedback loop. We're going to normalize and score this data, and we're going to continue to improve that. So that quick little bit of code that we saw, the goal is to keep expanding that as much as possible. Right? At some point, you'll need to refactor it to make it a little more manageable. But you want to make sure that that's where your efforts are going. Because right now, what's really happening, and what this process fundamentally addresses, is even though your SOC is processing at maybe 10% efficiency, you're losing any added advantage. Because they process an event and they move on to the next one. Where's the learning? Where's the improvement? This is what we're doing. As they process an event, put that back into the Lambda code so that the next time that event comes, it doesn't hit their desk. Because it's been scored and normalized away and it sits and you know it's a low risk or a low severity. Right? You're actually taking advantage of the efforts of the people you have processing all these events. Which means we're going to repeat this a lot. Like an absolute ridiculous amount. There was a machine learning talk given by 2 AWS engineers from the EU 2 years ago. And I'll never forget the sound in the crowd when they explained the volume of data they were dealing with. So they came out and they said, yeah, so we created this machine learning model to try to determine if a VPC log was bad or not. And we started with 1,000 logs, and their accuracy was somewhere around like 12%. It was ridiculous. And they said, so we went to 10,000 logs, and it bumped up a bit. And we went to 100,000 logs, and it bumped up even more. And when we got to 1 million logs fed through the model to train it, we finally got a reasonable level of accuracy out of the model. They were in the 70s. They said that until they got into the dozens and dozens of millions of logs, nearing like 100 million logs, that was when their model actually generated legitimate results. Okay, now the good news is security generates an insane amount of events every day. So you can get to that volume really, really quickly if you curate it so that we get it to the point where we can feed it into the model efficiently. So those are the keys there. When we have the loop running, we want to keep it running. The goal of this loop is to improve and maintain your data quality. Okay, so you don't just have a random collection of logs. You have logs that make sense for your usage, right? You have logs that have context embedded in them. That makes it easier to draw insights out of them. We're going to keep increasing automation. Remember that little left turn you can take right at the start? Because you're processing this information, you can actually start automating more and more, right? Most of the security folks said you're familiar with Lambda. Lambda's pushed from intelligent events or actionable events. It's a great automation hook. It's less work for us, which is great. We want to build and train the models once we've got this data set curated, right? And this is an entirely different process. This is an entirely different talk. Fortunately, there's the AI Summit this afternoon, 1 to 5. There's a bunch of talks dedicated from industry and academic researchers around AI, around model building. There's a ton of great information. I highly recommend on the AWS website, they just released all of their internal machine learning coursework, free to use for everybody. So Jeff Bard tweeted it out. It went out on the AWS blog. I think it's machinelearning.aws. Don't quote me on that one. But if you Google machine learning AWS, it was trending on Hacker News this morning. They've made this entire course available for all of us to do for free. You just need to pay for the AWS resources consumed. So it's a great way to learn how to build models, how to train them, how to maintain and deploy them. And then you're going to deploy those models into the loop. So the idea is once you get to the point where you're using machine learning will then start to go before your, or after your initial Lambda, before it goes to your people. Is that you put that machine learning model in place so that that is processing and making the initial decisions so that we're only getting high confidence, high value events going to our people to continue to review using Athena and using QuickSight, but also to take action on. That's the overall process. I hope you found that valuable. I hope that hit a nerve for you and gave you that potential solution. I know it's a difficult pathway. I would love to give you that easy, like, push this button and we're winning. It is a lot of work, but the sooner you get to work, especially creating that data set, the better off you're going to be. You'll get to that point where you can deploy trained machine learning models to really amplify the talent that you've got in your security team and to hopefully improve the stability, the reliability, the security of the builds that you're working on within AWS. Thank you very much. I appreciate it. You can always hit me up online at MarkNCA. Trend Micro, like I said, we have a booth at 2115 in the Venetian. Also, please remember to fill in your breakout scores on the app. They use that to figure out where to put everything and who to bring back, all that kind of stuff. So I'd appreciate any feedback. Thank you very much. I hope you guys have a fantastic day.